Hi, thanks very much. It's not exactly the same. That was a really fascinating talk. I did go to that one when it was on, and that work's carrying on. It's quite interesting. But this is actually stuff in user space, but for doing kind of interesting things. When I started using Linux a very long time ago, uh, I started poking around to find out how it worked, because that was the great thing about Linux, was that it was all there and open. You could find out how things worked. And I just started with init tab and how the system booted and started as a sort of starting point, and tried to follow everything through. And you could kind of do it. There was sort of shell scripts and stuff like that, and sometimes you had to get the source code of things and look at it and try and understand it. But that's how I started learning about Linux all those years ago. And recently I've been using Linux containers to do lots of things, and for running sort of little processes that are isolated and doing stuff. And there's this sort of assumption with the containers stuff that you want to run a whole Linux distro in each container, which gets really complicated and messy. And I thought, was there some sort of simpler way I could just, make something really simple just to run one program in a container, or with a bit of networking and so on. So I had this kind of dumb idea that, why not just make some simple scripts that will just enough to boot a simple system that can do some bit of networking, basically start a few programs and basic stuff. I mean, how much work could it be to make a little did to do this? I didn't have much idea, so I thought I'd give it a go. Obviously, it turned out to be a bit more work than I thought, and it's not finished. But I picked Lua, which is a programming language I'm quite fond of. It's really small and simple. It's about a tenth of the size of Ruby in terms of the binary, and it's kind of like JavaScript in the prototypal inheritance, quite nice to use. And I picked Lua JIT in particular, which is a JIT compiled implementation that is very fast and has really, really nice, really easy to use interfaces to C, which is good because the kernel interfaces are all C, basically. And this foreign function interface, FFI, works at native C speed. Pretty much it gets compiled in, so it's really fast. You can run system calls and stuff basically pretty much as fast as you can in C. And it's being used for several other low-level projects. There's an interesting one here, which the guy's working on building an Ethernet switch with Ethernet drivers in it. So it's good fun, and it's really quick to develop in. So I've been building this over the last couple of years, really. Start off with system calls, which are mostly done. You can call most of the system calls, a few left to do. There's all the data structures that come with them, all the struct, stat, socket addresses, lots and lots of these things. Then there's a lot of constants. Every system call, you look at the man page, and there's a list of 20 constants. There's IOCTL, which I've done some of, but there are infinite numbers of them, and they're all different and inconsistent, so I've only done ones as I've used them. I've got netlink support working. Netlink is the new interface to talk to the networking subsystem, so you can create network interfaces, give them IP addresses, create routes and those things. That was quite fun to implement, really, in a high-level language, because it's designed to be used with C macros, really. And it's not terribly well documented, other than looking at the source code and trying things out and so on. So that was quite fun. And then there's support for different architectures. I tested stuff on ARM and 64 and 32-bit, and recently PowerPC. I want to do MIPS as well, which was good for finding bugs and finding the weird things that are different. All the constants mostly have the same values in different architectures, except the ones that don't. There are a whole lots of different weird things that you find are different, which you never knew about. It's a good learning exercise doing all this stuff, by the way. So here's a simple example of basically creating a socket, setting a socket address, binding to a port, listening on it, and then feeding it into an ePOL so you can listen for events on it later. So as you can see, you can use strings for your flags, so it understands which flags are supposed to be in which place. So these are the C flags that you'd use. So, and you can just use commas instead of having to do or, bitwise or on the flags. And then there are sockets have methods for bind and listen. It's kind of the colon is the Lua object notation. So and things like file descriptors are garbage collected if they go out of escape, so which will then close the socket. So it's kind of easy to use if you're, even if you are not a C programmer and don't really understand how kernel-y stuff works, you can start learning it. This is netlink, so this is creating a dummy net interface. This is from the test scripts because I do a lot of that. You can set change the MAC address, set an IP address on it, put it up and down, delete the interface, so you can create VLAN interface, all the things that you can do with netlink. There's a couple of different syntaxes. This is an object with the interfaces, and you can print it, and it'll print out something that looks pretty much like ifconfig with all the information about the interface. So it's kind of quite easy to work with network interfaces, much easier than just shelling out and calling ifconfig or IP. And you can do the same thing with routes and so on. So it's kind of, I find it it's quite satisfying that it's kind of quite easy to use. The hard bits, libc and the kernel don't provide exactly the same IPI. The libc does all sorts of compatibility things, and it varies depending which. Run this with different C libraries for compatibility testing. The worst thing is 64-bit files on 32-bit CPUs, which are just horrible. Muscle just doesn't support, just always gives you 64-bit, which is nice and clean, but if you basically call stat or something like that, you don't actually know what it's going to be. So quite often I just call the syscall interface directly if for compatibility reasons. I spent a lot of time on testing, so there's a complete test suite that calls all the system calls and checks that it's created the network interface it's supposed to create, and it's got the IP addresses on it, and checks, say, through using sys interface as well as through netlink and so on. So it does some seeks more than 64 bits in a file and checks that it's actually got the position it expects and so on. What's the point of this now I've made it? Prototyping networking code, I find it's quite quick. You've got a high-level language with string operations, which is, if you just want to knock together a quick interface, it's fast. And you can always convert it to C later. It kind of reads fairly much like the C, but you can just knock something together quite quickly. General network programs, you can do asynchronous stuff, sockets, and it's fast. You can do 20,000 requests a second on a kind of dummy thing, because it's basically C type speed. Learning, you can just try stuff out. You're less likely to get seg faults, so you can do it if you try, but you don't have to. You can just give it high-level Lua types with tables instead of creating all your kernel structures, so you're much less likely to make stupid mistakes. There's some example code, mainly the tests, but I've got a repo of examples, but some better documentation would be helpful for people who want to learn about Linux but are not C programmers and want something higher level. I mean, I'm a C programmer, but I still like programming in kind of high-level languages sometimes. It's fun. Simple Linux containers, that was my original use case, which is kind of getting there again. I've got a sample, and there's a sample repo that's got a really basic thing that brings up a container with a network interface that's bridged across, and you can run a little program in it. It needs more functionality, but it's kind of there. And my aim is just build a whole, whole environment that runs, say, a web server or a program that you can just build the whole thing. It just builds the whole environment. You can test everything, and then you can just run it. It's quite quick and fast and simple, because I like simple things where you can understand the whole system and there's less really to go wrong. The roadmap for things I want to do. I used LuaJIT because it was quick and easy to do. I'd like to pull it straight Lua, partly to do the MIPS support, because there's no LuaJIT support for soft float MIPS, because the OpenWRT, that kind of thing, that uses Lua as a config language. And I think this might be a good fit for some of the stuff they're doing, so I'd kind of like to get in a state where it's possible to try that. documentation, really needs documentation. More APIs, particularly IP tables, Setcom, SE Linux, that kind of thing, so that you've got a bit of security support around your system images. If you don't like Lua, you could port this to another language. The only language I looked when I started this, and the only kind of language that seems to have a really comprehensive Linux kernel interface is Go. There's little bits in Ruby. There's a half-functional netlink project, but it seems a bit doesn't seem well supported. I couldn't find much else. It's a fair amount of work, but I think it's worthwhile for a scripting language to have this kind of interface. Everything's on GitHub under. This is the main repository, but there's a few example repositories. This talk's in a repo on GitHub. Legit.org. I'm on Twitter or email or raise a GitHub issue, send some code, fork it. That's it really. Questions? Well, yeah, the nice thing actually is you don't have to, it's legit, everything is in Lua, you don't have to build it at all. You simply, I can show you actually on the, oh, it's not, sorry, this isn't my computer, so I can't see. But basically there is no build process. The entire thing basically is written in Lua. There is no C code at all in the project, so because of the FFI interface does all the C interfacing. So there is no build, you just do require syscall and that's it, and then you can start using it. And all the bits of the different architectures are it just detects your architecture and includes that at runtime. So there is no build process at all, which makes the build really simple. Yeah. Well, I mean, I looked at Go, but the thing is. Yeah. Oh, give him the mic. Yeah, give him the mic. No, you repeat the question. Come on. He's brought the microphone. Give it to him. He knows the question better.
You're actually having a mic fight.
Sorry, yeah. Looking back, that you've seen things like Go and what it has for low-level stuff. If you were to do it again, would you consider something like Go or another language when it comes to a simple init system?
The reason I thought about using Go, because it was around when I started this. I like the fact that it's interpreted, and so you can just write it, and there's no sort of compile stage at all. So, because part of the thing was this educational thing that you can just look at the code that's running and change it, and just type stuff in and try it out, and that really quite appealed to me. I'd use Go for lots of things. It's on my kind of languages I'd like to use, but I think that sort of immediacy where you can run stuff is really quite valuable as well, and so it's a different kind of use case.